Today in 7.6 we're going to look at another form of the quadratic function. This one is called the Vertex-Graphing form. So if we're looking at these graphs, we are asked to draw the axis of symmetry, label the vertex, and write the equation in standard form for each one. Okay, so I'm going to pause it. I want to let you do that. And then you can check your answers against mine, okay? On second thought, don't worry about putting the equation in standard form. We'll do that later. Okay, I'm assuming you've paused it and had time to put in the axis of symmetry and label the vertex. Okay, let's look here at any thing we notice. I'm going to erase this standard form just to get it out of the way. Okay, so I'm going to grab a highlighter. And let's see what we notice now about the vertex and the equation. Any similarities you see between this equation and this vertex? This equation and this vertex. Already, hopefully, you can see that some of these numbers kind of match. Opposite signs though, right? So in this first one, you can see in the equation it says +4. The vertex is -4. What about the y-coordinate of the vertex? Same sign, isn't it? How about these three down here? Yeah, opposite sign for the x. On this one, you'll notice, if I grab my pen back, here, +0 we could write in there, and it would match the y-coordinate. Here, if we rewrite the equation in kind of with the bracket, now it looks the same as the others, with the 0 matching the second term in this binomial. And the last one works with that theory too. So we're going to learn about this vertex graphing form, and this is the form you've seen right here in all these highlighted equations. And it's called the vertex graphing form because right from the equation it tells you the vertex. So let's flip the page and write that down. So the vertex graphing form is y equals, or we know that y is the exact same thing of f of x. So sometimes we write those interchangeably. Y equals a, that's the same a that is in the standard form of the equation. That tells us the concavity, multiplied by x minus, now this is the coordinate, the x coordinate of the vertex. We use the variable h, squared, plus, and this is the vertex, the y-coordinate of the vertex. The variable we use for that is a k. Okay, so let's write that in. Also, the vertex then happens at h, k. All right? And if you need to be reminded again, this tells you the concavity. If a is positive, then up. If a is negative, then down, right? Hopefully you know that. Let's move down to the next example. Okay, so we're supposed to graph this function. Now, in the past, remember, we would make a big table of values. We would pick random x's, and we would figure out what their y-coordinates were. It was a bigger deal, right? It took a while. Here, not so much, now that we have this form of the equation. Okay, will this open up or down? Let's look at the A here, and I'm hearing you through the computer say down, and you are right. Okay, it's concave down is the first thing we notice. Secondly, we know the vertex right from looking at this equation. The vertex is going to happen at this number, -6, remember opposite sign, comma, this number, same sign. Okay, so let's sketch that out. Okay, so draw your axes, x and y, and the vertex happens at -6 for the x, 1, 2, 3, 4, 5, 6, and +1 for the y. This is the vertex, and we know this opens down, so we're just going to sketch it. We don't know exactly how wide it is, and that's okay. Just from looking, how many roots does this parabola have? Now remember, roots are the places where it crosses the x-axis, here and here. How many? Yeah, 2 roots. We know that just from that quick sketch and seeing how many times it crosses over. Okay, what's the domain and the range of this function? Okay, domain we know for all parabolas is all numbers of x. These rays on the parabola continue on to infinity, so we can have all possible values for the domain. The range, however, does have some restrictions. We see here that the y value does not go above right here. That's 1. So the range, we say y such that y is always going to be less than or equal to 1 in this case, because it's opening down. It goes down, the y value goes down to negative infinity below 1. Well done. In this second example, it's talking about the parabola created by a soccer ball. A goalkeeper kicked the soccer ball from the ground. It reached a maximum height of 24.2 meters after 2.2 seconds. The ball was in the air for 4.4 seconds. Okay, so we can picture that, I think. We've got grass. Well, how good I have green even. We've got grass, right? We've got the soccer ball, I'll use black. And it goes up and it goes down and hits the ground, right? And it says in the question that it reaches a maximum height right here, if that's the y-axis, of 24.2 meters, and after 2.2 seconds. So this maximum height happens here at 2.2 seconds, and then of course we know that that middle, that very tall spot, divides the parabola in exactly half. So it also tells us that it hits the ground after 4.4, although we could have known that on our own as well. So we are supposed to write the equation of this parabola, or this quadratic. I might as well write this vertex. This is x, comma, y. Because we know the vertex-graphing form, of a quadratic equation, it's this, or you can turn back, a times x minus h squared plus k. We can fill that in, and we know pretty much everything we need to. We've got h of 2.2 squared, and a k of, that's the y value of the vertex, that. Now, it's okay, I said we know almost everything we need to. We don't know the value a. We do know that a should be a negative because this parabola opens down, but we're not quite sure. So we need to put one other point in. You see, we know the k, h, we put it in. We know the k, we put it in. We don't know a. So what we need to do is put in a y that we know and an x, so we can solve for k, or a, sorry. So there is one other point on the parabola. Now I know this point 0, whoops, you can't see it. Let me scroll down. I know this point 0, 0 is the easiest. We're not going to use it. We are going to use this point, 4.4, comma 0, as our second point. Remember, all ordered pairs are x, comma y. In the bottom right corner I'm writing right now. So instead of the y, let's put in 0. A is what we're looking for. X, we're going to use the 4.4 they gave us, and that's why they said that in the question, so that we would know for sure that extra point. Okay, let's solve for a. We do, of course, inside the brackets first. Right, bed mass. Then we do exponents. And which is 4.84 when I square that. Okay, now usually we don't put the variable multiplied by the number. We usually write the number in front of the variable. So I'm going to rewrite that. Okay, now next we do addition, or sorry, now we subtract here, both sides. So we want to get A all by itself, right? That makes 0. So we have negative 24.2 equals 0.84A. I'm not sure why that did a little highlight there, but that's fine. Okay, we're still trying to get A by itself. 4.84 is multiplied by A, so we divide both sides by that. Again, if this math is just taking your time up and you know how to do it, then just skip forward. And in this case, A is equal to negative 5. And I'm glad it's negative because the parabola is opening down, so that's good. Okay, so now let's write this final equation. And where can I put it to where I can see it? Right here. Okay, so I'm looking now here. And we're going to put the A in that we found. So y is equal to, again, you could have written f of x is equal to A times x minus 2.2 squared, that was the x coordinate of the vertex, plus the y coordinate. Shazam. That is the equation that you could write of the path of the soccer ball. Well done. Okay, let's look up and see if there was more questions here. Did that. How is the equation of this function similar to the equation that oh, that was from the previous question. After 4 seconds, how high was the ball above the ground? Good question. Okay, so we kind of have a sketch of this. After 4 seconds, we can imagine that would be, 4 seconds would be about here. It's about that high, right? How high is that? Well, let's use the equation we just calculated. So x is the distance, or sorry, x is the time, the variable along there. So let's see what we get when I put a 4 in for x. Okay, use your calculator and figure that out. Pause it now if you haven't. And when you unpause, and your calculator says 8, and was that meters or feet? Meters. 8 meters above the ground after exactly 4 seconds. Now, if you didn't get that, when you're typing this into your calculator, you need to do brackets first, so the subtraction. Then you need to do exponents, so use square whatever you get from the brackets. Then you need to do multiplication, multiply your answer times negative 5. Then you need to do the addition. Okay, bedmass, folks, bedmass. Alrighty then, and your assignment, should you choose to accept it, was on this page, right down here. There you go. Okay, good luck with that. Ask questions as you need to.